Thank you very much for this opportunity. Good afternoon, all audience. So today's topic, I'm going to talk about identification and developing databases of extreme precipitation events in the peninsular region of India. So both the speakers who spoke before me, actually, they talked about two different things, and my talk is going to be like it's a combination of both the topics that they have talked about. So there is going to be some statistics, and then there is going to be some physics in terms of extreme precipitation events. So this is a brief introduction about the group from IIT Hyderabad. So the hydroclimate complexity group, we try to understand the extreme events, multi-scale processes, and prediction in gas basins and east-west forecasting. So in this talk, mostly I'm going to talk about the extreme precipitation event, the identification, methodology that we are going to use, and then develop a database which ranks these extreme precipitation events. And then I'm going to talk more on a case study and from Koilpatnam event that happened in the southern part of the country. And then we're also going to talk about some results that we got. So we can see like every few months we keep seeing like in the newspapers that monsoon has like a lot of extreme events are happening, and then that resulted in huge number of damage and deaths and all those things. And we can see a statistics that showing that the number of extreme events over the last few years have actually drastically increased, both heavy rainfall as well as extreme heavy rainfall. And most often we see a lot of intense rainfall that is happening all across the country. So you can also see that there are certain studies which have shown that what would be the future in terms of the global climate predictions or the projections in 2081, that we can very clearly see that when we focus into the Indian part, we can very clearly see that in most of the monsoon months, the intensity is going to increase in terms of percentages, the number of extreme event days. So the motivation comes from the idea that we wanted to develop a database for the extreme events. If we want to really understand what is the kind of event which or the kind of mechanisms by which these event has been triggered and what is the genesis of this event, we wanted to understand. Even though we have some numbers like this is the total precipitation on that particular day, we are not very clear about the mechanism which has actually caused those precipitation events. And so the idea was that we wanted to develop a database which is very critical, particularly when we are looking at the history, what has happened during that particular time. So here we are looking at two different aspects, like why do they occur? Maybe as Dr. Niranjan said, it could be a thermodynamical or it could be a dynamical changes that is happening. So here we are only focusing on, even though we have done an analysis at a national scale, but we are presenting the results only at the southern peninsular part. So first I'm going to talk on the identification of extreme precipitation events. So how do we do it? So basically there are different methods like people are using, like you say certain fixed value, maybe 100 mm, and anything about 100 mm is called as an extreme precipitation events. So our IMD uses this idea that okay, anything above 64 mm, we call it as a high precipitation event. That is a kind of a fixed value that you fix it. The other method could be a percentile approach, that you take a certain data and then say the 95 percentile of that entire data, we call it as an high precipitation event. Or we can also use the block maxima, where we consider an annual period and then say that one value from each year becomes a maximum value, and that you consider to be representing the extreme value for that particular year. So the problem with these different methods is that there are some subjectivities there in the first two methods. In the third method, like block maxima, we are going to miss, suppose there are two extreme events happening in a year which are very close to each other, maybe 100 mm and the other one is like 85 mm, 90 mm. So we are not going to consider the second event, which is second maximum event, in our analysis. So we are going to miss that information. So here we are going it's a very old methodology, even though but there are certain issues are there with peak over threshold. Here we are going to define a threshold which is not based on certain subjectivity, rather we are going to use the model to identify the threshold for a given region. So we are going to use the concept of general Pareto distribution, where we assume that the extreme value theory assumes that anything above a certain threshold is going to follow a distribution which is nothing but the general Pareto distribution. Now the problem is like how to identify that threshold for a given region or given particular point. So that's the biggest challenge, because you cannot arbitrarily assign a certain value and then assume that okay, this is the threshold for this region. So we need to have a certain statistical principles which the model or the data should follow in order to call it as a general Pareto distribution. Okay. So the idea is that I need to select a threshold which should be high enough to focus on the extremes, but not too high that only few exceedances are there. Okay, so I'm not getting into the mathematics of the general Pareto distribution, but there are very well known methods are there which are called as the threshold selection methods, which are based on proper statistics. So some of them include like graphical methods, automatic threshold selection, and the hybrid methods. So each of these methods have their own advantages and disadvantages, but some of these methods are mostly based on the idea that how well the data that you are extracting, how well the particular threshold that you are giving is going to give us some exceedances. So those exceedances should follow a GPD distribution. So how well that particular exceedances are actually following a GPD distribution, that is what we are testing. And it's kind of a search method that we need to search for the threshold. So we came up with the alternate methodology where we come up with a hybrid method where we combine both the traditional and the multi-threshold methods, which was developed some time back, and then we came up with the multiple threshold goodness of fit method, and then we did a lot of analysis using synthetic samples and then also with the real in-fall data sets. And what we could see that we applied this entire methodology that we proposed to the gridded data. Yes, there are certain problems with the gridded data. We may not be able to apply it, but the idea is that we wanted to understand how well this model is able to pick up those thresholds. So we applied it for the entire nation in terms of the gridded data that we have, and this is what we have got the threshold values for the entire country. So what we can see very clearly is that each of there is a lot of spatial heterogeneity is there in terms of threshold. That, for example, the place we can see the west coast, the Kerala region, we can see that the thresholds can be going up to even 100 mm. So anything that is greater than 100 mm is going to create a extreme precipitation. It's going to be called as an extreme precipitation event. On the other hand, in certain regions, even 35 mm or 40 mm could be a statistically significant extreme precipitation event. Okay, so the idea is that somebody may ask a question that it may not be actually causing the same flood impact. Yes, obviously true, but here we wanted to understand the statistically which are the extreme precipitation events if you want to do an analysis or you want to create a database. So that's the idea. So these are some of the parameters that we have considered in the generalized Pareto distribution model: the threshold, the shape, and then you can see very clearly the shape is nothing but the thickness of the distribution function, the generalized Pareto distribution function, where we can say very clearly that if the shape value is very high, that implies that there is a possibility that as Professor Bruno Merge was saying, that they're all like low, like it's going to be high impact, but it's going to create a low probability. It's high impact, low probability events. So same way with scale, it talks about the dispersion of these particular events from the mean. And so what we did, we just also applied, so we just zoomed in and then we looked into the different aspects of the southern peninsula region, and then see, we can very clearly see the threshold values are ranging from actually 10 mm to more than 140 mm, and we can very clearly see the spatial heterogeneity of the threshold values across the different regions. Now, instead of arbitrarily selecting a certain value and then counting number of events in a particular location, we can actually choose these thresholds to actually have a more physical understanding to get to the idea that how many extreme events have happened in that particular point. So we applied it for the entire annual time series also at the monsoon or the seasonal level. So these are some of the daily as well as the monsoon shape parameters that we have obtained. So now we come back to the ranking methods. So basically, ranking methods are generally popular when we are looking at. So one of the popular method that people use is a normalization method. So where we try to understand a particular event based on the climate, historic climate, and then we understand like what would be the standard deviation or the normalized value of that particular event. So we consider that x minus mu divided by sigma, where x is nothing but the event value, mu is the average value or the mean value of the precipitation, and sigma is the standard deviation. So with that standardized variate, we just rank the values. So now what people have done is that instead of just considering at one particular point, they also consider how they are spatially extending, these rainfall events are spatially extending. Okay, so with that idea, normalization method was developed, And when you come to the weather extremity index, it's a kind of a, you develop a generalized extreme value distribution and then estimate the corresponding return periods of the event. So instead of just considering the z value, they're also considering the corresponding z. Maybe it could be 100-year return period rainfall, or it could be 200 return period rainfall. So according to the return period values, the extremity is also going to keep increasing. And here also we can consider the areal extent of those events on the particular day, and then we can try to come up with an index called as extremity index. So we are also proposing a method. It's called as the peak over threshold (ZPD) method to estimate the uh, weather extremity index, and then we'll see how each of these methods are able to capture these events. So here in the normalization event, as I said, that we are going to calculate the z, or the anomaly value, okay, and then this is the precipitation at a particular time and a particular location, and then you have the mean value of the precipitation over the past history, and then if you divide it by the standard deviation, you are going to get a certain value. So what we are going to do is that we are going to consider the area, like, okay, or the points or the grid points which are very close to that particular point where you are looking at, and then see how many points are actually crossing the 2 sigma, and that also shows that the rainfall event that is focused on one particular point is spread in that particular region. So likewise, we can generate a list of extreme events, and then we can order them and then come up with the ranking of rarity. Okay, so we can very clearly see that there was an event which happened in the southern peninsula, very close to the Chennai region, and then it has happened in 14th of June 1996. And there was another event which is having a rarity of 947, which is like having a is localized more into the west coast of Kerala, and then there are also there are events which are spread very close to the Andhra Pradesh region. So likewise, we have actually categorized around 1,600 events for the entire period of 1951 to 2020, and then this is the list of the top 10 events in terms of their rarity. Okay, so so the idea of the other index is called as a weather extremity index, where we try to develop a model using the generalized extreme value distribution, and then we find out the return period for the each and every corresponding extreme event, and then we multiply with that area of those events. Okay, we are also assigning certain weights for the other grids corresponding to the return periods that is being experienced by that particular grid. Okay, so similarly, using this particular thing, we also identify certain number of events for the same time period, and we can very clearly see that there are another set of events that came into this list. Okay, so those events which were not present in the methodology proposed by like normalization method, and we can very clearly see that there are other events are present here. We can see clearly here, and you can see there is a recent event which happened in Chennai on a day we received rainfall around 451 mm, and that was on 6th of December 2023. And you can also clearly see that there is another event in 19th November 2021. There was an event in nearby the middle part of the Tamil Nadu region. And I would like to take your focus on this particular event where I am actually moving my mouse here. We have this event which happened on 18th of December 2023, which is actually a highly localized event, which happened in a place called as Kayalpattinam, which is very close to Kanyakumari or Thoothukudi region. So the amount of rainfall that was received by that particular location is around 946 mm. It's almost close to 1 meter of rainfall happened in that particular region. Okay, and there are also, we can see very clearly, there are a small localized event that happened here which is receiving rainfall around 200 mm here, that is also getting captured. So when we look into the two different methods on comparison, what we could say that the methodology, the normalization methodology misses out on very localized events. Okay, the event where particularly when driven by convection, it's going to be very localized and it might produce a very high intense rainfall when the aerial spread of that rainfall event is not so much. But when we consider the WI or the GV based method, it uses the annual maxima, so obviously it's going to miss those events which are going to be second or third, that maybe in that particular year there may be 2 or 3 events maybe consecutively happening, maybe a period of 1 week. So obviously our method does not going to rank or even consider those events here. Okay, so on the other hand, the proposed WIGPD is able to capture both the localized event as well as the spatial extent, also considers the event which are not the only maximum in that particular year. So quickly I'm going to go through the analysis. Like, we did an in-depth analysis of that particular event which was ranked highly in all the methods. For example, the WIGV ranked this particular event in Kyle Pattinam with a rank of 5, and then WIGPD with having a rank of around 11. So why this event is important? So you can see this is the location where I'm going to take you. Like, this is the Kyle Pattinam region, very close to the coast of Tamil Nadu here, and it received a rainfall around 950 in 24 hours. So a lot of even though a lot of people actually had difficulties in terms of their houses draining, and then they are completely immobilized in terms of even one train which was carrying around 600 passengers left stranded in one particular place for 48 hours. The passengers could not go anywhere outside the train, they are stuck in the train, and people nearby villages provided all the necessary things for them. Okay, so but this event did not receive much of attention because it was very far away from city, and cities are the only thing that the medias are actually focused. Okay, so that is the need that we can very clearly see, that there is a need which, like, we need to provide come up with a database or an event base where we could clearly categorize and rank all these kind of events which are really missed by these media. Okay, so we did an in-depth analysis of the extreme precipitation event in Pattinam. Okay, we considered two different mechanisms wherein we tried to use the ECMWF era data, and we try to understand what could be the causing factors or what is actually happening during that particular event. So we can very clearly see that the ERA dataset is not able to actually capture the actual precipitation, but it is able to capture that there is a high precipitation event that is happening in that particular location. Okay, so it was capturing around 175 mm on that particular day. Okay, but when you consider the average precipitation that was happening during that week for the past, maybe the in the past, we can very hardly see that there is no much of rainfall that is going to happen in that particular. So there is no any kind of a seasonality or climatology driving that particular event. So when we look into the integrated water vapor profile, we can very clearly see that there is a lot of water vapor present in that particular location, and then there is a transport that is happening from the West Pacific, and also there is a transport that is happening from the Bay of Bengal link. So you can very clearly see this is again the integrated water transport profile on that particular day. We can see the directions, and they were also plotted the anomaly behavior from the climatology of that particular location, and very clearly see that the anomaly is very high in terms of the Z value. That means it's an extremely extreme event. So we also looked into the sea surface temperature normally, and we can very clearly see that there is a high amount of warming of the Western Indian Ocean, and there is a cooling of the Western Pacific Ocean. So these conditions actually favor the movement of air mass from this Western Pacific to the Indian Ocean side, and we can see the geopotential heights during the week of 18 December. This is an average phenomenon, and we can very clearly see that there is actually a kind of circulation that is happening at both different geopotential heights. One is at 850 HPA, and also at 500 or even lesser than that, 200 HPA. So when we looked into the particle tracking mechanism and then try to understand where exactly the air mass is actually moving from, we saw that there is one chain of air mass that is moving from the Bay of Bengal wing, and then it's taking a lot of moisture from the Bay of Bengal, and this is a normal retreat monsoon or the northeast monsoon that we generally observe. But when we looked into the other geopotential light, we could also see that there are also particles that is actually coming from the West Pacific, and they're also taking a lot of moisture from these region. So there is actually two different branches of moisture coming and then getting converged into this particular location, and that actually caused kind of instability, and then a lot of rainfall happened. So, and then we can see the convergence moisture on that particular event day. It's around 660 kg per meter square, and then we also plotted the divergence, and then we can very clearly see that there is a convergence at the lower level and divergence at the higher level, which is the characteristics of the strong cumulonimbus clouds. And these are some of the velocity, and we can also try to relate with the ENSO and the IOD values of those particular time, and we can very clearly see there is a positive correlation between the ENSO and IOD values with this particular event. So we also try to understand this phenomena using the WOF model, and then we could to some extent try to simulate these results, and then we we can very clearly see that there is a need for analyzing these events and then trying to understand the genesis and then come up with a proper database with the mechanism with which these events are getting produced. The event database should not just have the values of the precipitation that has happened on what day, rather it should also understand the physical mechanism which with which these events are getting produced, and that would provide a better understanding about the events. So that's the idea that I would like to present. So thank you.